Okay, moving on. All right. Which of the following represents how many moles of the unlabeled compound, or yeah, which of the following represents how many moles of the unlabeled compound present in the flask before cooling? Okay, so this seems like a question typo, but what they're asking is how many moles of the unlabeled compound are present in the flask before cooling, and then they give you the gas constant. Okay, so R in your PV equals nRT is 0.08 liters per liters ATM per mole Kelvin. Okay, whatever. Cool. All right. So at first, okay, this question looks extremely daunting, but it's really not. Okay. So look at the options. Okay, what is really different about these options when comparing them to each other, right? So we see 402 is the same, right? We see 0.082 is the same, okay, and we see 1.013 is the same. So it's very straightforward. I know some people are going to see this and immediately, I don't know if they let you guys use calculators on the MCAT. I don't think so. Again, it has been a while, so a lot of things might have changed. But this is not something that you need to see and panic. Okay, when you see questions like this, kind of look at them a lot more closely, and literally you can eliminate options without even having to do any math. Okay, so PV equals nRT, but that's not what these equations are representing, right? Because we're looking for the number of moles. So this will be N. Okay, so and even without a piece of paper or a board, which I'm pretty sure they'll give you on the MCAT so you can write. I honestly don't remember because it was so long ago, but even for like our medicine, shelf exams or modular exams, or, they give us like boards, to be able to write on. So I'm pretty sure they would for the MCAT. But so when you get your board, they're asking for the moles. What you want to do is change the subject of the formula. So PV equals nRT. If you changed it around, it would probably give you whatever this is. So I'm going to try to deduce it just from the values here. Okay. So this 402 looks like, so you would do the change of formula to arrive at this, but just to work backwards, I would say, okay, so this is T. I mean, sorry, this is T, our temperature. Okay. So N equals, okay, so this is T, this is R. Okay. So going by this, the thing we can change the most to find moles, this looks like volume, and it would be volume. Okay. And this is P. Okay. So N equals P times V times R, or N equals P times V. Yep. Over, okay, R times T. Okay. And literally, if you do the change of subject formula, that is what you will get. I am 99.99% sure, because you never say 100% sure. 99.99% sure. Okay. So now that we've gotten that out of the way, okay, so everything else is the same. What changes is this, right? What changes is this. So it's like, okay, yeah, this should be our volume, right? It should be our volume. So what is our volume? Okay, we found out the end. It was measured to be 160 milliliters. Okay, I see 160 here. Do I go ahead and pick this right away? No, no, because it's in milliliters. They're trying to trick me. They're literally trying to trick me. This isn't liters. The unit of the constant is liters per ATM per moles per. Even the pressure, right? Remember, this was 1013. Where is it? 1013, right? 1013 has been changed from millibars to ATM to atmosphere. So you got to watch out for those changing units. And sometimes they just secretly, sneakily hide the units that things need to be over here. So, yep, this isn't Kevin, and yeah, okay, so cool. Volume. So 160 milliliters to liters. Okay, so We know that 1,000 milliliters makes 1 liters. It's like elementary stuff, right? It had us memorizing this in elementary school. So 10 milliliters make 1 centimeter, all that stuff. So 1,000 milliliters equals 1 liter. Okay, so we need to divide 160 by 1,000. So that automatically eliminates this. So if we're dividing this by 1,000, right, it's 3 zeros. So you got to move the decimal point three places. So one, two, three. All right, so 0.106. And I can bet you, I don't know what I'd bet you guys, but that is most likely the answer. Okay, let's see. Yep, good job. And 73% of people got it right. Awesome. So again, this just goes to show you don't need to panic. You don't need to pull out your calculator. You don't need to automatically start calculating. I've spoken to a few students, and you know, sometimes I get it when I completely understand because I've been in your shoes before. When you're learning information newly, or you're seeing something, or you're in an exam situation, things can get a little tense, a little scary, but trust me, things always work out if you keep a level head and use your judgment and your best assessment. And you don't need to be the smartest person in the world, right, to score really high on the MCAT. You just need to be clever, okay? And you just need to be able to take information as you see it and utilize it, okay? So this pretty straightforward. You don't need to pull out your calculator. You don't need to, try to calculate or, try to figure it out from scratch. Like literally you could just eliminate options based on what you're seeing. Okay. So cool. All right, moving on. All right, based on the experiment's results, the unlabeled compound is a what? So you put in an acidic solution with oxidizing agent. Okay. But remember, oxidation is loss. We're putting it with an oxidizing agent that's going to take away the electrons from it. Okay. And an acidic solution and bubbles were formed. Um, doesn't really make sense. Acid, ketone, again, we said, man, like, no, right? This is like, I think, such a bad distractor. Base, not particularly. A base wouldn't do that. Alcohol. So, if we oxidize an alcohol, this is from Ochem. And if you oxidize an alcohol, oxidize it really well, oxidize it, really powerfully, you could get a carboxylic acid. Um, you could get a carboxylic acid. So we're putting, this unlabeled liquid, right? Or 10 milliliters of this compound that we got in now. Using this ideal gas setup, water bath arrangement, we've put it with an oxidizing agent, and now it's in an acidic solution, and bubbles are formed. We're trying to releasing gases. Got to be an alcohol. I am like 90% sure it's an alcohol. Let's see. All right, cool. And only 44% of people got this right. I wonder why. I think this is just one of those questions where like you kind of just know the answer. So there's questions that are inferable, right? You kind of have to think through it. And this is one of those like, what is the powerhouse of the cell type of question. You just have to know it, right? So one of those things where like, OChem, okay, if you oxidize, yep. So primary alcohols can be oxidized to aldehydes or carboxylic. Yeah. So if you oxidize an alcohol really, really well, continuously for a long period of time, you could get a carboxylic acid. So it makes the most sense to do, right? So yeah, let's see why the other options are wrong. Acids are not oxidized. Yep. However, they enhance it. Yep. Makes sense. Ketones are resistant. Yep. So like ketones is a no-brainer. Like, ketones, nobody would try to oxidize a ketone, right? All right. Bases are more likely to, yeah, bases are reducing agents. Yep. So, okay. So remember, review your oxidation reduction. So bases are reducing agents. Why? Because reduction is gain of electrons, and bases have a lot of electrons they want to give. Okay. So, um, Cool. Yeah. Alcohol makes the most sense. This is one of those XP questions. So, guys, what I'm trying to say to you is get as much XP, as many XP points as possible. And I know XP points is kind of redundant, but get as much XP as you can. Experience points, experience points, experience points, guys. Like that is the way. In medical school, it's gonna be about experience points. You can, study 100%, know the material from front to back. If you're not utilizing it, if you're not putting it into the test, if you're not putting your knowledge to the test, if you're not, using that knowledge to solve problems, you're not doing yourself any good. So XP, 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 you have to be applying the knowledge. You have to, have to, have to. Okay, so continue to apply your knowledge as you practice. All right, moving on. All right, so we're done with the questions from the passage. These are just freebie questions. I'm just gonna